This was just looking at a graph and trying to identify some qualities by looking at that graph. So your points may not have been exactly what mine were because I don't think these were perfect on the graph. Domain and range. I'm just going to try. Okay. So let's assume if this keeps going, as time goes on, then this would just get wider and wider. So domain, what x's do we end up hitting eventually?
All of them.
All of them. Range. We go bottom to top. So this is going down forever, so it's coming from negative infinity. Stops right here at our highest point. So what was that y value? 3. Since we hit it, it gets a bracket. B. Zeros are where you hit the x-axis. So it's these 3 places. So those x values, looking at your graph, were?
-3, 0, 1.
-3,
0,
0, and 1.
Then 1.
C. I want to know where the function is greater than 0. So greater than 0 was right here. So that starts when x is 0 and ends when x is when it hits it again, which if you look at your graph, this is x equals 0, that's x equals 1. They get parentheses because I just said greater than, not greater than or equal to. Maxes and mins. Okay. So we have local and we have, should I say absolute? Absolute means it's the highest or lowest on the entire graph. Do we have a single point that's the highest one on the entire graph?
Yes.
Yes, right here. So if you look, I think on my answer key I did function notation. You could just write that ordered pair. It's hard to tell exactly, but I think it's about 1/2 positive 3. That also counts as a local max. The only thing that doesn't count as a local max is endpoints, but as long as it's in the middle of a count. This one, what would that count as?
Minimus.
It's
Local min.
not a minimum because it's higher.
Oh, yeah, so
Local max.
It's a local max as well. It's not the absolute because it's not the highest on the entire graph, but it's higher than the points on either side of it. So that was at -3, 0.
Wait, the half and 3 was local max too?
It counts as both. All right, what's this one? Local min, because it's lower than the points on either side. So a max would be like that. A min looks like this because it's lower. So this is a local min, and that point is at, it's hard to tell exactly. I think I said -4/3 and -8.5. If you said like -1.5 and -9, that's close enough. It was hard to tell exactly. So as long as you're in the ballpark on that, I'm good with it.
Okay, so absolute max is the highest on the whole thing. Local max is if it's higher than another point, and then local min is if it's lower than another point.
Do we have an absolute min on this graph? A point that's lower than everything else? No, because the ends keep going down. All right. Is that good? 24. We need to talk about these. One thing I want to stress on 23, you solve those equations. Like on A, you should have gotten -5 and 2, but the final answer is only -5. Why? Right, if you put it back in and you put in a 2, you get 0 on the bottom of the fraction, and we cannot have that. If you plugged on B, you get x equals -3, but can you put -3 back in the original? No, because that gets us a 0 on the bottom, so that one's just a no solution. All right.
Can we do B then? Because I didn't get it right.
Okay.
what you get?
Fractions?
Alright, so we have to factor this one, so multiply to 15 and add to 8 would be 5 and 3. So we know right now what two things can x not equal.
-3, -5.
Okay. If I want to get rid of the fractions, to get rid of this one we have to multiply by x plus 3. And if you do it to 1, you do it to all of them. Alright, if I want to get rid of this one, we multiply by,
X plus 5.
so if you do it to 1, you do it to all of them. So we're left with 1 times x plus 5 plus 4 times x plus 3 equals 2. We get 5x plus 17 equals 2. Subtract over the 17. Divide by 5. Instead you get -3. But we already said x can't be -3. So our final answer is no solution. So 24, this one's different because of the inequality. We can't use the same strategy because when you have an inequality, if you multiply by a negative, that inequality flips. Do you know if 2x plus 1 is positive or negative? No, so we can't just multiply it over to the other side. Instead, what we had to do had to be set up like this. So fraction on one side, 0 on the other. Then we had to set the top and the bottom equal to 0. So we get x to be a -2 and a -1/2. And then we made this little sine line. So grab a graphing calculator. And we want to graph the original. Include parentheses around the top and bottom. So we have x plus 2.
Teachers, at this time, please keep all students in your classroom until they are released by intercom. Thank you.
So if we look, this part is above the x-axis. So that means we're really looking to see if it's positive or negative. If it's above the axis, that's positive. So until we get to -2, that part was positive. After -2, the graph drops below, so it was negative. And then at -1/3, we jumped back up here, so this section was positive. We wanted less than or equal to 0. Less than 0 would be negatives, right? So that's from -2 to -1/3. Now equal to,
half.
oh, thank you. I don't know why I did that. Equal to would mean brackets. However, this is wrong, how I have it written. Does anyone know why?
Should be a parenthesis.
Yeah. Why do we have to have a parenthesis there?
Because it keeps on going.
Where does the half come from?
The denominator?
The denominator. Can the bottom of a fraction equal 0?
No.
No. So we can't actually have the 1/2 because we can't have a 0 on the bottom. So it has to get a parenthesis. Whatever's on the bottom gets a parenthesis no matter what. Is that one okay? Let's look at B. So we had, all right, I told you we want the setup of the last one, which is fraction on one side, 0 on the other. So we have to subtract over this 2. That's like a 2/1. if I want to put them together, they need a common denominator. So we have to multiply by 5 minus 3x on top and bottom. So we have 6 over 5 minus 3x minus 10 minus 6x over 5 minus 3x. So we could distribute that negative. So 6 to the negative 10 is negative 4 plus 6x over 5 minus 3x. So we've done the work. At this point, all we've done is turn it into the problem that we have in part A. So now we're ready to use that strategy. So we're ready to set top and bottom equal to 0, and then look at the graph. So if you want to know when the top equals 0, maybe my board is not working at the moment. We get 2/3. Set the bottom equal to 0. We get 5/3. So those are my 2 points here. Now we graph. We want to graph this one right here. So put parentheses around top and bottom. So when I look at this graph, it starts off below the axis, so that's our negative. Then it goes above, so that's our positive. Then it's back below, so it's negative. We wanted greater than 0. So greater than would be positives. There's no equal to, so everything gets a parenthesis. So my positive section was just between 2/3 and 5/3. Is that one okay?
Mm-hmm.
25B. So you need to remember your asymptotes. To some degree, you can use your graphing calculator, but you want to be very cautious with that. Use a graphing calculator to kind of check yourself, see, does it look like, I wrote down that the horizontal asymptote is 0. Does that look like where it is on my graph? But you can't just solely rely on it, because sometimes it's hard to tell exactly. So vertical asymptote is always x equals a number. And that number is what makes the bottom equal 0. Horizontal asymptote is always y equals a number. And there's 2 cases. You get y equals 0 if the top degree is smaller. You have to divide the leading coefficients when they have the same degree. So if it's like 2x squared over 3x squared, then it's y equals 2/3. Oblique asymptote is going to be like y equals mx plus b. And that only happens when the top degree is 1 bigger. Okay, if it's more than 1 bigger, there's no horizontal, no oblique. So if we look at 25B, vertical asymptote, x equals what makes the bottom 0?
2.
Okay, what is the degree of the top?
2.
Degree of the bottom?
1.
So the top is 1 bigger, that means it's oblique. We do long division. The top goes underneath. Some people, we like to put zeros sometimes if you're missing a power, just help things line up. The denominator goes out in front. So then we divide. What is x squared divided by x? Then you multiply. X times x is x squared. X times -2 is -2x. Change your signs because we need to subtract that off. So the x squareds cancel. 0 plus 2x is 2x plus 4. And then we divide. 2x divided by x. And that's all we need. So our oblique is y equals x plus 2.
Where did the 2x come from?
When I added, okay, so I had to take this x times that whole thing. So x times x and x times 2.
Oh.
Other questions? So 26, you asked about B. Should I talk about A?
Yeah. I just don't know, like, when it's bounce or through.
Okay. So it probably wouldn't hurt to run back through all this stuff.
And the empty
All right, so first thing is the degree. The degree is saying how many x's are there. If you multiply this out, what would be the highest power of x? So if I multiply it, I have an x, and an x squared. So altogether, I would have x to the 4th. So my degree is 4. In behavior is based off that degree. If it's an even degree, it looks like a parabola. So both ends pointing up. But there was a negative in front, so that flips it. So both ends are actually pointing down. Zeros. It's already factored, so we just have to figure out what makes each parenthesis equal 0. What makes x minus 4 0? What about x minus 2? And x plus 2. And since that one's squared, it's a multiplicity of 2. Okay, the next step, bounce or through. It's based off the multiplicity. This is like a 4 multiplicity of 1, 2 multiplicity of 1. If the multiplicity is odd, it will go through. So the 4 had an odd multiplicity, so it goes through. 2 had an odd multiplicity, so it goes through. -2 had an even multiplicity, so that one will bounce. Then I asked for the y-intercept. So y-intercept is when x equals 0, so if you plug in 0 for all of your x's, we get -32. Now I don't have you find this stuff just for fun. I expect it to be plotted on your graph. So we know the y-intercept is -32, so that's where we hit the y-axis. We hit the x-axis at -2, 2, and 4. So my graph started down because both ends are pointing down. I hit at -2, and we said that should bounce, so we are going to bounce off. Have to hit our y-intercept, come back, hit our next 0, we said it went through, the next one we go through. So it ends the same direction we said. You can confirm this with the graphing calculator, but your graph has to have the zeros, the intercept, marked clearly, make sure it's curved, and make sure you know how to find all of those pieces by hand. is the same thing, but it's different because it's not factored already. So your degree, that's the highest power when it's all multiplied out. But if I'm looking at this, it is all multiplied out right now. So what is my highest power? 3. So when it's in factored form, like the parentheses multiplied, you add them all together. But here, it's already multiplied out, so you just get the biggest one. So end behavior, if it's an odd, it looks like a chair. There's no negative to flip it, so it's down up. And if you really get confused on that, you could always look at your graphing calculator and confirm that you had your graph pointing in the right direction. To get the zeros here, we need to factor this. So both of them have an x squared. You could take out an x squared. And that leaves us with x minus 4. So if we set them equal to 0, this would just be a 0 multiplicity 2. And that one would be positive 4. Okay, bounce or through. So even multiplicity bounces. So 0 would bounce. What happens at 4? Y-intercept, if you plug in 0 for all of your x's, what do you get? You get 0 times negative 4, which is 0. So let's put the x-axis at 0 and 4, y 0. Our graph starts down here. At 0 we bounce, 4 we go through. So it should look something like that. It wants to know if it's 1-to-1. All you have to do there is look at a graph. So we have x cubed plus x minus 4. And what are you looking for 1-to-1? Yeah, does this pass the horizontal line test? Yeah. Anywhere you draw a horizontal line, it only hits your graph once. So it is 1-to-1. What does it mean? It passes the horizontal line test, which means we can find an inverse. So we could find an inverse on this. All right, and then 28 has us actually find an inverse. So remember, finding the inverse, there are certain steps. First step, you change f of x to y. Second step, you flip x and y. So my y becomes an x, both of these x's become y's. Now we have to solve for y, so we have to get the y by itself. So I'm going to get rid of my fraction. So it gives me xy minus x equals 3y plus 2. We need the y's on the same side, so I'm going to subtract over my 3y and add over this x. Okay, I can't actually add x, y, and 3y, but what could I do?
Take out a y.
So then we can So my inverse is 2 plus x over x. Gotta be equal, so that's alright, so domain of the function is equal to the range of the inverse. To find that, you just look at the original. When we have a fraction, the bottom can't be 0. So what can x not be? So it would be negative infinity to 1, and 1 to infinity. The range of the function is the same as the domain of the inverse. So we can look at the inverse. What can x not be there? So if all you're trying to do here is find the oblique asymptote, degree on the top is 3, degree of the bottom is 2. So we know that there is an oblique asymptote. To find it, we are going to do long division. So the inside is what was on top. If you want, you can put 0 for your missing powers of x. You don't necessarily have to, it just helps things line up a little better. What goes outside is the bottom. And again, this didn't have an x to the first, so if you want to put a 0, you can. You do not have to. So then we divide. So what is x cubed divided by x squared?
Okay.
Then we multiply. So x times x squared is x cubed. X times 0x is 0x squared. X times 1 is x. We have to subtract that off. So if you run a negative through, those cancel, and those cancel. So we just have 0 minus 3. Can I divide anymore? No. If you do 0 divided by x squared, you just get 0. So our oblique asymptote this time is just y equals x.
Wait, what goes to the, where's the -3 go then?
We just ignore it. Remember with the oblique asymptotes, we never finish the long division. We just stop once we get the slope in the y-intercept.
So it'd be the 0 then?
Yes.
Okay.
Okay, let's do one. So trying to think of things that would be worth a lot of points on here. When we had to go through and do all the graphing on these, that would be a lot of points. So let's practice one where we had to do everything. So for this, I would ask you to do certain things. So first step, I would say, factor the numerator into denominator. So can we factor the top at all? So we just leave it. What would we do for the bottom?
Negative 3.
Multiply to -4.
-2 and 1.
4
Or no.
-1.
Yeah. Okay. Then I'm going to ask you for the x-intercept. Thank you. Okay, x-intercept is when y equals 0. So if you set this whole fraction equal to 0, you'd multiply over the bottom, so you'd have 0 equals 3x squared. What do you get for your x?
0.
So my x-intercept is 0.
Do you have a piece of loose leaf? Sorry.
I got you.
I say I have like scratch paper. Y-intercept is when all of your x's are 0. So if you put in a 0 for all of these x's, what do you get?
1 over -4.
0 over -4, which is 0. So x and y-intercepts are both 0. Vertical asymptote. X equals, what makes the bottom 0?
-1, 1.
Horizontal or oblique? What's the degree of the top? degree of the bottom. So if it's the same degree, you divide leading coefficients. So 3x squared over 1x squared. So 3 over 1 is just 3. So now we can graph it. So y-intercepts are 0. Over asymptote at -4 and +1. Horizontal at 3. So then we use our graphing calculator to fill in the gaps. So I like to just graph the original, put parentheses around top and bottom. So the top was 3x squared, bottom x squared plus 3x minus 4. So we can see it starts up here, and it's an upside down parabola, and then it's back up in the corner. When you draw those in, please make sure it's curved and getting closer to your asymptotes. So it'll look something like
How do you find that horizontal asymptote?
So remember we had all of these rules I wrote out earlier? So if it's the top degree is smaller, it's an automatic y equals 0. If it's the same degree, you divide the leading coefficients. So that's what we did here. It was 3x squared over 1x squared. So 3 divided by 1.
Okay.
Other questions? Okay. Oh, hold on. Yeah, that's good too. So, if I asked you to solve this, what would you do first?
Combine.
We combine these into one log. Since those were added, you would have to multiply the arguments. So we have to FOIL. So 2x times x is 2x squared. Minus 8x and minus 3x would be minus 11x plus 12. If you have a log on each side, what do you do?
Drop them.
Then what can you do?
Get x by itself.
Okay. So it's a quadratic, which we normally set equal to 0. If we subtract over 12, it cancels. So what can I take out here?
Next.
That leaves me with 2x minus 11. Set each of those equal to 0, so we get x to be as 0 and 11. Am I done?
No.
We always need to check. There are lots of things on this this semester, that we need to check, like all of our radical equations, our log equations, our rational equations. So if you're solving something, I'd probably just check at the end to make sure your answer works. You can't have the log of a negative. So can I plug a 0 in?
No.
No. Can I plug in an 11 halves?
Probably.
Probably. That would give me that one's positive, that one's positive, so it works. So 11 halves is the only option here. So remember with those logs, your argument has to be a positive. Let's do another log problem.
Can we do it when we have to like put it into log form or the?
Yes, so like where you can't get a common base, is that what you're saying?
Yeah, like I would just like.
Okay, so let's say I asked you to solve this.
Add a log.
We can't get a common base. If we could, we'd want to do that. We can't, so we add the log, and part of that we like because the exponents drop down in front. So we get x log 2 minus log 2 equals 2x log 3. So we need the x's on the same side. Both of these terms have an x in them. Mhm. So then to get x by itself, you just divide. So we have negative log 2 over 2 log 3 minus log 2. And you could put that in your calculator and get a decimal if you prefer. What if I gave you what would we do here?
Get the log on both sides.
So, since not everything has a log, we want our logs on one side. If 2 logs are subtracted, how do you combine them?
Divide.
Since it's only on one side, in order to get rid of the log, we have to do the definition. What is the base of this log?
10.
10. So it'd be 10 to the first equals x plus 5 over 3x minus 5. So we can multiply the 3x minus 1 over. So we get 30x minus 10 equals x plus 5. Subtract over the x, add over the 10. So x is 15.